Okay, this is term 1, week 6, physics CA. Did I download this? Yes. Okay, 14 pages. I'm gonna go through it very, very fast because صراحة very, very easy. Mostly formulas. Okay, أول شيء electric field. It wasn't asked in the quiz. Oh no, no, we don't. It's not required. Electric field, skip it. It's not required. But electric field, it has its own equation. Okay, F over Q node. Okay, whatever. La 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 la. This is about a single positive charge. It always electric field is okay. It's is there a description for it? كتبتها شي مكان. Yeah, it's always flowing from positive to negative. So basically, they represent current. So if you have positive, it's gonna move away from it. That's it. Okay, it's gonna go always from positive to negative. So if you have positive negative, it's going like this. Positive to negative like this. This is obviously it's gonna move through the negative. If it's too positive, they're gonna move away from each other. Okay, and this is called a neutral point. In case it comes, probably won't. It's not the material. Okay. Okay. The movement of electric currents involves the ordered movement of electric charges. What do I mean by ordered? I mean it moves from positive to negative. Okay. In metals, the electric charge carriers are the conduction electrons that are free. In metals, who carries the charges? The free electrons. Okay. You have to know this. Electric current can be defined as the flow of electric charge. By convention, electric current flows from positive to negative. Okay. This is opposite to the flow of electrons. Electrons flow from negative to positive. Okay, this is important, you know. Okay, a galvanometer is used to detect very small current. So this is here. This is a galvanometer. You connect it to the positive. You connect it to the negative. If there's current, it's gonna go. Okay, you see this dashed arrow. This is the shaded arrow is the original one, and if there's current, it's gonna be the dashed arrow. It's gonna go like pew. Okay, the galvanometer will detect current. This is an experiment to detect current, if they get it. And I'm not doing the same mistake as I remember one AMS. After that, every experiment we do in class, everything in the book, I'm taking it down. I'm taking down all the steps. After, excuse me, after that one AMS that we had with that one question of the experiment, I started writing everything. Anyway, so here you have a Van de Graaff generator which generates positive charges, and they connect it to a rod. And here we have some negative charges. Okay, so what happens is this is a neutral ball, and you have a galvanometer down here. So what's gonna happen is the ball will swing back and forth. As it swings, the meter will detect current, right? Because it's gonna go here, it's gonna go here. The meter is gonna start detecting current because when it hits this, it's gonna gain positive. Okay, the positive will then repel it to go to the negative, right? And that positive, when it goes to the negative, it will lose positive charges, right? And then this positive charge will go down to the galvanometer. Okay, so it touches plate A where it receives the positive charge, then repels to plate B where it loses that positive charge. So it touches plate A and it receives a positive charge. Then, since it's positive, it now repels back to plate B where it loses that positive charge, and that positive charge goes down into galvanometer. Okay, and it keeps on going. This shows that the static charge carried by the ball is the same which flows through the meter. They could all come multiple choice, huh? So what does this show? This shows that the static charge carried by the ball is the same one that flows through the meter. Yani, the charge that the ball carries, it's the one when it hits B, it's the same charge that when it hits B goes through the wire, صح? Okay, what does شو Van de Graaff? Okay, I don't know what I meant when I wrote this صراحة. Van de Graaff flow of electrons. ما بعرف والله. Maybe I think the Van de Graaff is used to see the flow of electrons. I have no idea صراحة. I don't know what I meant here. Okay, electrolysis. You guys know electrolysis is when you split water into ions. And you guys know if there's more ions, there's more conduction. I think what I meant here is just conduct, whatever. I don't know what I wrote here. In metals, okay, only electrons can flow at a rate of 1 millimeter per second. Okay, in metals, only the electrons can flow, right? Nothing else. This is in metals. That's what causes metals to conduct electricity. Energy tends to dilute itself into matter. What do I mean? It means it goes from hot to cold, from more energy to less energy. It's always rich donates to the poor, right? When you want to remove an electron, you must supply energy, right? This is normal. When you want to remove an electron, energy must be supplied, right? Let's say you have, I'll explain. I think I wrote the explanation here. You need two forces. F1, which is the force that overcomes the attraction forces in the nucleus, and F2, the force that overcomes the repulsion of the electrons if you connect. Okay, if you connect a conducting wire. Okay, let me show you. Over here, عندك positive nucleus, عندك electrons, right? Let's say you want to remove this electron. You guys know that the positive nucleus attracts these negatively charged electrons. So أول شيء you need the force F1 that overcomes the force between the positive nucleus and the electrons, because there's a force holding this electron and this nucleus, right? So we have to overcome that. Then there's also the repulsion of the electron. Yeah, there's also شو قصدي أنا هون؟ Oh, yeah. So if you want to remove the electron, you have another atom here. Yeah, I remember. Right, you have another atom here. So you want to bring this electron here. You know, since you have these negative electrons that you're bringing here, you know there's going to be a repulsion force, right? It's going to be repelling it. So I also need another force F2 that overcomes this repulsion force to force it in here and stick it into the atom. Stick it into the atom. My fault. Okay. If you connect a conducting wire, okay, between A and B, let's see, the flow of electrons will be from B to A, because B is the negative one, A is the positive. You know, electrons always go from negative to positive, and I will move from A to B. What is I? I is electric current, okay? What is the formula? I equals the Q divided by the time, okay? Q is the charge in coulombs, I is electric current, and T is obviously time in seconds. In SI units, the current is always in amperes, A, where 1 ampere is 1 coulomb per second. These are all CA questions, guys. You know, they could come. Okay, هلا, you have 2 points A and B. They are said to have a potential difference. We call it PD. I'm going to start calling it PD from now, okay, because I don't want to keep on saying potential difference. Okay, they have a PD between them if, when charged, you know, I'll just say potential difference. Let me not be fancy. Okay, to have a potential difference between them if, when charges move spontaneously from one to another, electric potential energy is changed to some other form of energy. If, okay, VAB equals VA minus, I think they meant here, this is A, this is B. Okay, VA is greater than VB, or, okay. So let's see, you have A and B, right? The potential difference between VAB is equal to the potential V of A, V. Potential difference is voltage, by the way, huh? Okay, is equal to the voltage of A minus the voltage of B, right? Because we know it's going to flow from positive to negative. What happens along the way? Let's say here you started with 5 volts. Here you're going to end at 4.9. Walid, how do you lose 0.1? You can lose it either to friction in the current or resistance. You don't need to know this, but you just need to know that at the positive terminal, there's always a higher potential difference than the negative terminal, because you start at here. Like, think of it, when you're running a race, you have the race, this is the finish line over here, okay? I don't know. Okay, you're starting over here. You're gonna start with, I don't know, 100 joules of energy, and when you finish, you're on life support. I don't know, depending on what race you're running, whatever. You're on 20 joules. So across this race, you lost about 80 joules. Think of it like this: the electrons or the current is running through a race through the electric circuit. That's how it loses some هيدا. Okay. Potential difference is measured in terms of how much energy is given out by each coulomb of charge that passes across these 2 points. In other words, energy is W, charge is Q, so V equals W over Q. In other words, and I like to say W equals QV, okay? These are, you need all these formulas, okay? Go through the notes, all the formulas are written there. Okay, SI unit is volt. 1 volt is 1 joule per coulomb, because energy is in joules, Q is in coulombs. You could also say W equals QV. Okay. هلا power. And did I reach the circuits? Okay, yeah, that's there. Power, very easy. I'm gonna come back to it again, I think. No, I won't. Power is the work divided by the time. You don't need these now. Okay, you need these two. Okay. P equals W divided by T, and P equals IV. These two are very important. Okay. Power is work divided by time. Also, power equals IV. Why? Let me prove it for you. Power equals work divided by time. Work is equal to QV divided by time. Q is equal to IT, right? So P equals IT times V divided by T. Cancel, cancel, you're gonna get P equals IV. I just derived for you P equals IV from P equals W over T. Okay? Very easy, easy to memorize. Okay? These are just questions. Okay, kilowatt hour. The kilowatt hour is the energy consumed in 1 hour, obviously, by an electric device having a power of 1 kilowatt. Okay, guys, this is very very يعني شيء سخيف كتير. Okay, you guys know power equals energy divided by time, work or energy, whatever. Power has a unit of watts, right? So 1 watt is equal to 1 joule per second, right? What the kilowatt hour is they found the energy. They found a new unit for energy. They just multiplied power by time. Okay? We know energy, let's just say, I don't know, energy W is going to be equal to power times time. You know, power is in watts, time is in this case, they're using hour. Okay? And since they're using a bigger unit of time, they were like, oh shit, you know what? Let me just put a kilo here. Okay? That's just what's happening. Very, very, it's just a unit of energy. Okay? 1 kilowatt hour is equal to 1 kilowatt times 1 hour, which is equal to 1000 watts, because kilowatt is 1000 watts, times 3600 seconds. So 1 kilowatt hour is equal to 3,600,000 joules, okay, which is equal to 3.6 times 10 to the power of 6 joules, which is equal to 3.6 mega joules. Okay, هلا طولت كثير على النوتس، خلينا نمشي أسرع شوي. Okay, an ampere, okay, this I'm gonna show you from the book, because they ask some questions about this. An ampere is a reasonable amount of electric current that flows in many household appliances. Ampere, we said, is current. 1 microampere is 10 to the power of negative 6. These are important prefixes that you should know. Micro is 10 to the negative 6. Nano is 10 to the negative 9. But pico, P, is 10 to the negative 12, but they don't ask it. So that's why I didn't write it. Very small currents may flow in terms of milli and microamperes. A coulomb is a small quantity of charge that may flow through an ordinary lamp every second. It is not a reasonable amount of static electricity. Okay, a coulomb is not a reasonable amount. Let me open the book for this, because they gave some examples of some appliances at home. هون ولا بالEMF if it loads بكون نصيب. Okay, where am I? Okay, electric energy consumption. Okay, بديش KWH. Yeah, here. No, this is, we don't want this. Yeah, so here, this is an AMS question, and it was in the quiz, okay? Most appliances draw currents between 1/10 of an ampere and 10 amperes, okay? So about 0.1 ampere to 10 ampere. Low current devices, the lowest current devices are like lamps and light bulbs. Okay, lamps and music players are the least. They draw about 1/10. Then you have after them filament lamps and televisions, okay? Filament lamps are different than fluorescent lamps. Filament lamps have a different chemical, okay? So fluorescent lamps and music players are the least. بعدين عندك filament lamps and TVs, okay? Because these ones use LEDs. These ones here use something else, okay? These ones need about 1 ampere. And then high current devices like kettles is هيدا اللي بسخنوا فيها مي, you to boil water with it, and washing machines, okay? You know, washing machines, of course, it takes a lot of electricity. For people in Lebanon, especially where I come from, نحن عنا if the load of the electricity becomes too high or higher than what you're paying for monthly, it's gonna, like, the whole generator shuts down. You'd have to reboot it, okay? And usually there are two things that take like a lot of electricity. It would be washing machines, and then also what's higher above it, air conditions and heating systems. So مثلا if I want to turn on the AC in my house in Lebanon, I'd have to make sure that the washing machine is off, because if I turn on the washing machine and the AC at the same time, it would be too much load on the electricity in my house, and therefore the generator will shut down. So just an example to help you understand. So air conditioning and heating system, also same thing with the water heater. Water heaters take up a lot of amperes. Okay, here. Okay. Yeah, I guess just read this. If a sphere charged to 1 coulomb, we said a coulomb is not reasonable. If a sphere charged to 1 coulomb was placed in the middle of a classroom, light objects would leap up and stick to it due to the effects of induction. Everybody's hair would point towards the sphere. La 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 la. Basically, I think what they're trying to say is a coulomb is too big. Okay, نحن we use less. Okay. Yeah, that's it. Go back to the notes. Okay, هلا ال EMF, electromotive force. This is very important. I'm gonna help you understand it. Okay, we call it electromotive force, but it's important to know it's not a force. Okay, look, battery, positive, negative. You connect it to ما بعرف a circuit. Okay, I get the voltmeter here. الفولتميتر صح؟ والفولتميتر هون الباتري it gives me 15 volts. الفولتميتر بيعطيني 14.78 volts. You can say طب وليد what happened to the other 0.22 volts? I'm gonna tell you they got lost. Okay, so here, very very easy. The original voltage that you have, the energy supplied by a generator, that is what we call the EMF. This is the energy supplied. بعدين the final voltage you get, this is what we call the potential difference. They're both in terms of volts, but one is bigger, one is smaller. Okay, the smaller one is potential difference, the EMF is 15, the bigger one. Okay, electromotive force. Okay, so the energy supplied by the generator to the coulomb is not all transferred. An electric generator is a device, this is a definition in the book, it's a device that converts a certain available form of energy to electric energy. You know, generators, they give us electric energy. Okay, so what they're trying to say, the V of AB is equal to the EMF, the electromotive force, when there is no current, right? When I turn it on and current starts flowing, what's the voltage going to be equal to? It's going to be less than the electromotive force when there's current. Why? Because some energy is lost as resistance or friction, whatever. In conclusion, the electric motive force is the total voltage transformed by the generator to electric energy. I don't know why I put energy divided by charge, but okay, you know, because V equals W over Q, W or E. Some people call it E, some people call it W. Transformed by the generator to electric energy. بعدين هلا I drew for you a few ones here. Here you have 6 volts and you're just connecting a voltmeter. Okay, it's gonna give you 6 volts. But هلا when you draw a circuit and there's current flowing, you have a lamp over here, it's gonna become 5.8. وهون كمان you connect 2 lamps now, it's gonna become 5.6. So the more you connect, the voltmeter will begin to read less. This V plus RI, no need to know it. I think. Yeah, I don't think you don't need resistance for now. You don't need resistance. Okay, هلا see book page 102 because I was not about to draw every single symbol in the book. Okay, we're gonna go through these, we're gonna fly through these because at this point most of these are pretty self-explanatory. Wires, okay, they look like this. A cell, this is a cell. This is a battery of cells. Okay, this is like many cells grouped together. Wires joined, and this is a junction. A junction is where wires meet up. Okay, like here, this is a junction, مثلا. Okay, that's what a junction is. This is a fixed resistor. This is a variable resistor. Okay, this one here is an alternative for battery if it's just like this. Okay, this is a capacitor. Okay, it's 2 positive terminals. Or no, I don't know, it's just a capacitor. This is a rheostat or resistor with moving contact. Just memorize it. This is a variable resistor. This is a galvanometer. This is a potentiometer or potential divider. I don't see the difference between these two, but they don't ask these. They're not very popular. This is an ammeter, we all know it. Signal lamp. This is a lamp, and this is filament lamp. Okay. This is a voltmeter. This is a clock. Okay. This is a diode or a rectifier. This is a fuse. This shows that you're earthing or grounding. This is a switch, a keyed switch. This is a heater. This is an AC supply. This is a thermistor, okay, and the coil of wire or inductor. Yap. Okay, these are very important because they might ask this in the computer. It wasn't in the quiz. When wires are bent, you need to have right angles. هيدا they might show you which of the following represents a correct electric circuit diagram. إذا بيرسم لك هيك ويحط لك ما بعرف باتري وسويتش هون ويحط لك الباتري هون. Okay, هيدا غلط. بتكبه بأول زبالة because you need right angles. Okay, for the corners. You see how it's bent at a right angle. Okay, هيدي كانت تمشي بgrade 9 و grade 10 بس هلا بgrade 11 you're not allowed to do this. When wires cross each other, always shown as lines crossing each other at right angles, like I told you. When wires are joined, a round blob is used, which represents a junction. This is the junction. When the current direction needs to be shown, arrows are needed to indicate the proper direction. This is a very nice example of how you draw a circuit. This is an open circuit أكيد because the switch is open. وهون they're supposed to draw an arrow for you هيك to represent current. Anyway, عالسريع I told you. Okay, هلا a closed circuit is where current passes and there's an unbroken conducting path. Closed is when it's unbroken. Open circuit is where current does not pass and there's a break. صح? Okay, easy. Experiment. This is the experiment for a closed circuit. What does the experiment show? If you connect a wire between A and B, okay, يعني they mean here. Oh wait. Okay. Okay. This experiment, this is for the closed circuit. What they're saying is if you connect a wire between A and B here, what's gonna happen is the lamp will not light. Electrons will always choose the easiest path. They go up in a process called short circuiting. Okay. طب وليد, how is this the easier path? Isn't it longer to go like this? ما يا أخي no. أنا ما قصدي هيك. I don't mean the distance. أنا قصدي if it goes here, it's gonna have to start supplying energy to this lamp. And electrons, they don't like that. They're like, oh, there's an easier way for me to go without supplying energy. I'll do that. So that's why they go up here. They go like this. They go like this. They go like this. They go like this. This is called short circuiting. Okay, series circuits. Okay, this is grade 7 physics. Okay, in series circuits, all lamps have the same brightness because in series circuits, current is the same. If one lamp is unscrewed / broken, what's gonna happen to all of them? The circuit's gonna be opened and all the other lamps turn off. However, in parallel circuits, lamps have different brightness. If one of them is unscrewed, the others will become brighter instead of turning off. Why? Because unlike series circuits, parallel circuits divide the current among the branches. If one is unscrewed, there's gonna be more current left for the others, right? And that therefore they become brighter instead of turning off. I total is equal to I1 plus I2. So let's say you have I here. It's flowing. It splits off into I1, I2, I3, I4. The total current, when you add these up, will always equal to I. Hella, there's Kirchhoff's first law later. We're gonna get to it. That basically explains what I just said right now. Okay, parallel and series combination. You can always have a combination, okay, between parallel and series. I don't see why not. It's always... أكيد it's fine to have a combination. Okay, lamp C in this case will be brighter than A and B. Let's see why. The current I will split here into I1 and I2, right? I1 and I2. Okay, upon reaching the parallel circuit. When it branches back, it goes back normally as total, I total. And this I total will go into the lamp, right? So these lamps take only a piece of the total I, but this lamp here takes all of it, okay? Okay, ammeter, the ammeter and voltmeter, memorize. Ammeter should always be included in series. Okay, the polarity must be respected. If the polarity isn't respected, it's gonna give you a wrong reading. Okay, يعني positive with positive, negative with negative. The ammeter is used to measure current when reacting, minimize the when reading, minimize the parallax effect. Parallax effect basically means and look at it properly. Don't ما تكون صافن. Okay. And then here, the voltmeter, it's used to measure the potential difference or voltage, right? But we call it in grade 11 potential difference. Between 2 points in a circuit, we always connect it in parallel. If it's, oh my god, but if it's one circuit, make sure to connect the points only that you want to measure. Okay, يعني what I'm trying to say is عندك هون battery or cell. Okay, عندك هون lamp. You want to connect only this lamp, so you take هون هيك تحط لك voltmeter هون in parallel. Okay. Okay, Kirchhoff's law. He has two laws. The first law, very easy. The total current entering is equal to the total current leaving. Thing is, I just did this in class today. I don't know how it's included in the AMS, but it's not in the quiz, but it isn't included in the AMS. Basically, you have I1, I2, I3 entering. What the rule says is I1 plus I2 plus I3 is equal to the total current leaving plus equals I4 plus I5. ما في أسهل من هيك, guys. Super easy. Okay. The second law. The sum of the potential differences in series is equal to the potential difference across the whole branch. Okay, so the voltage of the battery is equal to the voltage of AB, which is equal to the voltage of CD, which is equal to V1, V1, V2. Okay. So you guys know that if you have potential difference here, it's gonna equal to the potential difference that's here, because that's equal to the potential difference over here. Always when you have parallel in like in branches, okay, the potential difference in the branches will always be equal to each other. Okay, the total. And it's a هون 12 هون 12 هون 12. Okay, يعني V of the battery here is equal to V of the cell, I should say, is equal to VAB, which is equal to VCD, which is equal to VL1 plus VL2. This is L1 and L2 here, so you get what I mean. Okay, okay, this is important. For a series grouping of generators with a positive plate, positive pole of one, you connect it to the negative one of the other. The total electromotive force is the sum of the individual EMFs. Okay, in this case, this is series. Series meaning you connect positive, negative, right? Okay, very easy. That means the total will be the sum of all of the EMFs. Let's say each one is 1.5 volts, 1.5 volts. The total EMF when you connect it, in this case, will be 3.0 volts. But if you connect it in opposition, it's gonna be the difference. What do I mean by opposition? يعني positive, negative, negative, positive. No. Have you guys ever seen a battery? هيك. هون البوزيتيف وهون النيجاتيف، صح؟ انت when you connect batteries in I don't know TV remote او ما بعرف شو, always you connect the plus to the minus, right? Always, because if you don't ما هتظبط. So if you connect it in opposition, the total EMF will be the difference, not the sum. Okay, it's the opposite. Grouping in series is used to get a larger electromotive force. If you group in parallel, you get the same EMF but larger capacity. What do I mean? If I have them, you know, I'll show you in the book. I'm not gonna draw it now. هاي the resistance mesh, it's not, we don't care about it. Okay. لا مش هون. Over here. Kirchhoff's law, grouping generators. Okay, هيدا البارallel هون. هيدا بالseries, you connect it like this, right? Positive, negative, positive, negative, positive, negative. You get the total 9 or whatever, how many you have. Hon, if you connect it in parallel, you're gonna get the total is 1.5 volts, but it's just a larger capacity. Okay? Because you have so many batteries now. Okay. خلاص هيك بنكون خلصنا. Let's go quickly to the quiz. Quiz is super easy, super easy. فيزياء هون. How long is this so far? Oof. I'll get it under 40 inshallah. I'll fly through these quiz questions. Okay. A battery of EMF is 5. Okay? EMF is 5. The bulb draws a current of 0.7. Okay? From the battery when the potential difference across the battery is 4.7. What is the amount of energy gained in joules by 1 coulomb of charge? Okay, so they gave you that Q is equal to 1. 1 coulomb is Q equals 1. They want the amount of energy. W is equal to QV. What's the charge? 1. What's the voltage? They're saying in the battery. In the battery. So, in the battery, it's always the EMF. The total, right? You know, in the battery, it's all, okay, positive, negative. Whatever is inside here, this is the total voltage. You might find your final voltage to be a bit less, but we don't care about that. We care about what's happening here, okay, inside the battery. They said in the battery, it's 5. So you can do 1 times 5, you get 5. What's the energy lost by 1 coulomb in the battery? How much did we lose? We started at 5 volts. We ended at 4.7 volts. Hella, you can just do 5 minus 4.7 because it's 1 coulomb. But I'm gonna do for you, it's the work inside, it's the energy inside the battery. I'm gonna use, I'll just use work. I'll use W instead of E so I don't confuse you. It's equal to the work in the battery minus the work that you actually ended up with, which is in, I don't know, the bulb, right? The work of the, let's just say lamp. Okay, the work of the battery, we found it's 5 minus the work of the lamp. How many? It's W equals QV. It's 1 charge, right? 1 coulomb. 1 coulomb. So 1 times the voltage V 4.7. You get 0.3. This is the correct way to solve in case they say 2 coulombs, 3 coulombs, but they never say that. They always say 1 coulomb. Okay, 0.3. So this is how much was lost, right? What is the amount of energy delivered in joules by 1 coulomb to the bulb and wires? How much voltage did we get? We ended up, we delivered 4.7. So the W is equal to the Q, 1 coulomb, 1 times 4.7. Q is charge in coulombs, huh? In case you don't know, you get 4.7. Super easy. Again, let's fly through them very fast. Okay, what is present here? This is so easy. Where do we see any resistors in series? No, they're in parallel, right? Two light bulbs in series, يعني حد بعض, they're in the same circuit, yes. Okay, two resistors in parallel, right? Connecting wires, يعني obviously, an ammeter, you don't see any A here, so ما في ammeter, very, very easy, guys. These questions are so, so easy. Okay, if bulb 1 is unscrewed, what will remain on? Let's see, bulb 1. Remember, the only time you'd ever have something turn off if you unscrew something else is when that something is connected in series. What is 1 connected in series with? It's connected with 3. So the only thing that's going to turn off in this case is 1 and 3. What's going to remain lit? They're saying which is going to remain on? 2, 4, 5, 6. 2, 4, 5, 6. Super, super, super easy. Again, we should fly through these. Okay, and this circuit is made of a battery, a lamp, and a wire in which A and B is marked. The electrons, in this case, where do the electrons move? Electrons move from negative to positive. So, from A to B. However, current goes from positive to negative. Where is the positive? B to A. Super easy, guys. Yalla. 5. Okay, in a circuit, this is direct application of the formula. Okay, 3 coulombs, so Q is 3. 0.6 seconds, T equals 0.6. What do they want? Current, I. What is I equal to? I equals Q divided by T. Right? I think in my book, in the notes, how did I write it? Over here. Yeah, Q divided by T. I thought I wrote Q equal IT, that's fine. Okay, Q3 over 0.65 ampere. Nothing harder. والله شو بدك أحلى من هيك. Direct applications of formula. In order to move 2.5 coulomb of charge. 2.5 coulomb of charge. Q equals 2.5. Okay. Against a potential difference of 24 volts. So V equals 24. How much energy? Energy بدون ال W. عندك ال Q عندك ال V. شو بدك أحلى من هيك? Just W equals QV. اضربهم ببعض. You get 60. يعطيك العافية. Question 7. In a circuit, 2 ampere flows across a potential difference 12 volts for 5 minutes. What is the power? Power is equal to, what do we have? We have I equals 2, and we have V equals 12, and you have T equals 5. The first 5 minutes, which has to be in seconds, I'm just going to convert it from now. The first equation for power is work divided by time. But we don't have any work here, although we do have time, so we don't have any work. So what are we going to use? We're going to use the other equation for power, which I told you to memorize, is P equals IV. Right? If you go back to the notes, you'll find it. Okay. What's the current? 2. What's the voltage? 12. 24 watts. Nothing easier. What is the energy? Energy. W. They want the W, right? Equals Q times V. Do we have Q? No. We don't have Q. Okay. Q is equal to, we know I is equal to Q divided by T. Right? So Q is equal to IT. So I can replace this Q by I times T times V. Do I have I, T, V? Yes, I have everything. I is 2 times 300. Voltage is 12. You get 7,200. But they want it in kilojoules, so you put 7.2. If you want an easy formula, energy, E. If you have time, you're going to use always IVT. Okay? 99% of the time, you're going to use E equals IVT. This is a formula, but it's not in the book. I derived it for you. You can use it a lot. Okay? It was actually in our physics when we were doing the MC delta T questions, IVT. What is the energy supplied by generated? Energy supplied to move from the positive to the negative terminal. The energy supplied, يعني they were talking about the total. شو اسمها? Electromotive force. Question 9. Okay. Here we have the current through resistor A is 1.1. So هون عندك 1.1. وcurrent through resistor B is 0.3. What is the current through the bulb? Okay, let's see here. How does this work? Obviously 1.1 plus 0.3, but I want you to understand. We know current moves from the positive. Positive is the long one, negative is the short one. So current moves like this, right? هلا it reaches a junction, right? So it's gonna split off into here and into here, right? And then they're gonna meet back up here to form the total current. What did we say the total current leaving is equal to? It's equal to the total current entering, right? So the total current leaving through or entering through the bulb is equal to the total current here. So 1.1 plus 0.3, 1.4. Kirchhoff's first law. Okay? His current law. Question 10. Okay, here in the diagram below, the potential difference across the battery is 3 volts. So the total is 3. across the bulb here it's 1 volt. يعني أكيد it went like this. It lost how many volts? 2 volts. But they're saying across resistor A, across resistor B. Walid, why are they both 2? Why isn't it 1 and 1? يا حبيب قلبي. Because in parallel, what did we say? Voltages are equal. Kirchhoff's second law. The second law, remember, is that voltages are equal. Potential differences are equal in branches. When it branches, potential differences are equal. Okay? Let me summarize for you. In series, or you could say in series, voltage is additive, right? And current is equal. In parallel, current is additive. Oh shit. Voltage is equal. نحن اكتشفنا that we're gonna have 2 volts here. Since it's in parallel with each other, they're forming branches, they're gonna be equal to each other. So إذا هيدي 2 هيدي it's 2. ماشي easy. Okay. 11. Okay. Variable resist. Okay guys, I'm not even gonna waste my time. Voltmeter أكيد V, lamp أكيد هيك, cell أكيد هيك, variable resistor هيك. والله ما في أبيخ من هيك أسئلة يا جماعة. Okay, this one like I told you. The least one is fluorescent lamp. If they told you, what was the other one? It was, نسيته. What was it? يا الله هذا بدي أرجع. Where is it? يا ربي. Okay, here. So the least is fluorescent, and then it's filament. Right, okay? Filament lamps and televisions اللي مع بعض. Okay, so least is fluorescent, then television أكيد, then washing machine, then AC. AC is it takes the highest. Okay, memorize this question. وكمان know from the book that AC is like the heating system. They take almost the same amount of current. television is like the filament lamp. washing machine is like the kettle. fluorescent lamp he like music player. Honestly, the regional is the type of person to get this same exact question but switch the ors. You see how like it says fluorescent lamp and music player? He's the type of person to like not put fluorescent lamp and just change it to music player, and not put filament lamp and change it to like not put television and change it to filament lamp, and then not put washing machine, put kettle, not put AC and put heating device. You get what I mean? So make sure you have it memorized. Question 13. Okay. On, off. Okay, what? Oh my god. Okay, here أكيد off. Here أكيد on. Here they put this one on purpose so they trick you. أكيد off. Why? I told you if you take another extra wire, the electrons will choose the easiest route. So if there's another path they can choose where they don't have to go through the lamp, they will choose. How many questions? 16? 16. Okay, this is here electric cell, this is resistor, this is lamp or filament lamp. You can just say cell, this is fixed resistor, whatever. 15. Okay. To measure the current through bulb A, the ammeter must be attached to point 4 and 5 in series. Honestly, series is obvious. Ammeter is always attached in series. But why points 4 and 5? And honestly, I still don't get it. It goes like this. Oh, okay. Current will move like this from the positive side. Okay, it's gonna branch here. بعدين it's gonna go continue like this. Now we want the current of bulb A. So akid we're gonna see between 4 and 5, right? If you were to choose 2 and 3, it might measure the current that's over here. We don't want that. Because remember, here it branches off into 2. And the current that I'm getting at current A is just what's over here, after 3, right? So that's why I connect it into 4 and 5. Okay? To measure the potential difference across bulb B, we want the voltage across bulb B. أكيد, for the voltmeter, دايما you connect it in parallel, right? Parallel. Between what? Always between the two, in between, the thing you're testing should be in between the voltmeter. So بتحط الvoltmeter here. Okay? هيك. 16. Okay, a 4.5 volt battery. Okay, هيدي 4.5 volt. Okay, is attached. The current is 50 milliampere. What's the current passing through bulb 1? Bulb 1, أكيد, it's gonna have the total current. right, in the battery. Since it's in series, the current here is going to be equal to the total current, which is 50 milliampere. Easy. The current passing through bulb 2 and 3. Okay, they said that the light bulbs are identical, meaning they draw the same current. So if here you're drawing I1, here you're drawing I2, these are equal to each other. We know that when you add up I1 and I2, how much are you going to get? You're going to get 50 milliampere, right? And we know they're equal to each other, so you can just replace this with I plus I equals 50 milliampere, which is equal to 2I is 15 milliampere. So you're going to get I is equal to 25 milliampere. Okay, very easy. Since they said identical and they have the same current. هيك بنكون خلصنا. يعطيكم العافية. Please don't forget to solve the grid questions, guys, or course revision document. Good luck tomorrow in your exam.